If you want to calculate the integral of a general curve, you can approximate the area under the curve with these rectangles here. So this rectangle here, it has its height here at the highest point. So this rectangle is a little bit larger than the area under the curve. But here, we take the height of this rectangle as the lowest of this part of the curve. So this rectangle is a little bit below the area under the curve. So the real value of the area under the curve of this part is smaller than this one, but larger than this one. And in the same way we do for all the others. If you now make these rectangles narrower and narrower, and we have more and more rectangles, then you will see that what we have above and below will get closer and closer to each other. So it gets closer and closer to the true value of the area under the curve. So the integral is if we take the area of all these rectangles and sum them. And in the limit we have infinitely many rectangles with a width that goes to 0. And if you take the sum of all the areas of these rectangles, we get an approximation of the area under the curve. And in mathematics, a sum is written with Greek S. And if you take the area of one of these rectangles, then the width of this rectangle is delta x. And if here is x, the height of this one is f of x, since this is the curve f of x. So the area of this rectangle is the height times the width. And then we should sum the area of all these rectangles. And in the limit we should let the width of each of these rectangles go to 0, meaning that we have more and more rectangles. Then we have a sum of infinitely many rectangles with the width going to 0. Then we change the S symbol to S symbol of this type, where we are summing from A to B. And this one goes to 0. And in mathematics, when you have a difference like this going to 0, you write it with a small d instead. So when this goes to 0, you write it like this, and it's called a differential. And therefore you have this part corresponding to this part of the symbol for the integral. So you see that the reason for having this notation is because it comes from a sum of infinitely many narrow rectangles, approximating the area under the curve. And this way of calculating the area is called a Riemann sum.